Hello everyone. I'm going to start off just with a brief presentation on Shelly, then I'm going to show you what the devices looks like, how it works. I do understand that not everybody is from the resi sector. There's a lot of C&I customers here as well. And the whole idea is just to show you how it works inside the C&I sector as well as the residential sector. So yeah, just brief introduction for those of you that don't know me. My name is Harold. Very excited about everything that we saw at Intersolar and also all the new integrations coming. So I'm going to start by sharing my screen. So yeah, Sigenergy smart home ecosystem, really excited about this. And it's not just based on Shelly, it's based on actually their new software that they've released. So yeah, just diving right into it quickly. Basically, the whole idea is to start optimizing energy usage inside your home, in your building, in your office. I'll show you guys later on that we've done it inside our head office here in Cape Town, and it's working really well. But the whole idea is to enable you to run a smart home or a smart building straight from your Sigenergy app. So it's about using your excess solar production. We all know that the solar curve is only during daytime. And this actually helps you optimize by pulling in your loads from the outside of sunlight hours into the sunlight hours. All right, so basically your solar will then propel your main loads, but also excess solar will then be able to go to smart loads based on priority. So dishwasher, washing machine, heat pump, your AC EV chargers, as well as any other smart loads. It can also extend your backup duration. So one of the nice parts about it is you've got this must-have, nice-to-have, and not really needed type scenarios. So if you are running in an off-grid situation or during a power outage, you've got certain items and you can change the priority that these are really must-have items. So angry wife, hot water, must-have item. Not so angry wife, not to have is the DSTV watching rugby. Again, on a Saturday, I reckon hot water takes a different priority than what watching the rugby game would be. Also then the real-time monitoring from it, you will be able to see historical and current power usage, also cumulative consumption and consumption ranking. So once you've added smart devices to your Sigenergy system, you'll be able to see which items are the highest load items and then prioritize which ones get access to the energy the quickest. Then also flexible access. So your Shelly ecosystem is one of the main drivers for smart loads, but then also the smart port on the gateway itself. As then another addition that they've done is the DO port of any inverter or any gateway can also now control any smart devices. So if you've got a gateway, your smart port plus the DO port is already there, plus every inverter has got a DO port. So in total, you'll be able to, if you've got 3 inverters running on the system, you can do basically 4 smart loads through those DO ports, bearing in mind that they are current limited. Then smart load scheduling, you can schedule to enable you to run excess solar power to your loads, also do a battery level control, and then the other schedule, which is based on AI, which is system dependent. So the system will learn, it'll realize which loads are more important than the others based on what input you've given it, and then AI will take full control of the system. And then the next one is obviously ready by. So in other words, if you want to have a certain device be ready by, so let's say EV charger, I want the car's battery charged by 8 o'clock in the morning, you can have that set as ready by, or hot water by 5 o'clock, you can have that ready by 5 o'clock. And then you'll be able to use your battery smartly. So you can control the loads based on the battery SOC. So a startup SOC and a shutdown SOC. So if the battery reaches a level, the fridge will go on or the device will go on. If the battery reaches a certain level, it will put the EVDC down or your fridge down or whichever load you decide to label to it. All right, so we'll dive into it just now. So here you can see the smart energy solution. So you'll basically have one smart load that can be on the inverter DO port. Then your DO port on the gateway will be able to, or smart load 2 will be your EVDC. So smart load 1 is the DO port, smart load 2, your EVDC charger. Then smart load 3, the DO port of the gateway. Smart load 4, for higher power loads, can be your smart port on the gateway side. Then on the gateway, you can also connect your EV AC charger, which can also be a smart load number 5. Then a Shelly devices for smart load 6, 7, and 8. This then means that on any Sigenergy system, you can have up to 24 smart loads. So if you take in a commercial, let's say residential living complex, so call it flats for argument's sake. If you've got a building, 24 flats, you can control 24 geysers individually off one big system. So the DO port would be remote control and smart scheduling. The smart port would be real-time monitoring. So DO ports do not monitor power output, they're just on and off. Where the smart port is real-time monitoring, remote control, and scheduling, and Shelly is also real-time monitoring, smart control, or remote control and smart scheduling. So basically, you can have the power measurement done on all of them. All right. Then next one, so it's fully compatible with Shelly. Shelly is a very nice open source platform. The devices aren't really that expensive. I see here they're talking about 22 euros. I think if we have a look at the pricing that we've got, it's a little bit less than that. So Shelly is quite big. So it's over 4 million households, over 18 million products sold and represented in over 100 countries. Adding a Shelly item to your app is really quickly and easily. You just enable the Bluetooth on your phone, go scan it. It'll pick up the device automatically. You add it, you connect it to the Wi-Fi. Once it's connected to the Wi-Fi, you'll be able to do all of the control through your Sigenergy app. If you are running a system like Homey, you can also add those devices into Homey Pro, which then enables you control from various platforms. Okay, so Shelly connection, super easy. Again, you turn it on. It'll pick up the device automatically. You'll say add device. You'll pick the network that you want to add it onto. Once you've done, it'll give you a list of various loads. So it's got various pictures on what it can be. You give it a name and you give it a location, and it's finished and done. And the system will automatically add it to your Sigenergy app. All right. So this is actually where the nice part starts. So you'll be able to measure and understand and customize all of your power consumption. So you will see what the basic load is. You'll see what the load is of the air conditioner, the AC charger, the fridge, the TV, the hot water, and the washing machine. So once you give this device a name, it'll basically separate the loads from each other. So here you can see that your individual devices, the basic load, so all of the normal loads was the highest, second highest was the EVAC, third highest was the fridge, then your hot water, all of that. Then your real-time view, you'll be able to jump into that device, look at what the consumption is. So you'll see what the load was for today, for the month, lifetime total of the load. And then as you go into it, you can actually see your time of use plus state of charge residual power, how it will look like. It'll give you the curves of what it will, how it will work and how it will not work. And then you've got your energy backup management that you can say that 50% I want to save for backup, 50% I want to save for time-based control, or you can slide that to have 60% for time-based control, 40% for backup, which means that it will run the dishwasher or geyser for 62 minutes. Make sure that the must-have devices do actually run that time. Your nice-to-have devices, it'll try run for that time. If it doesn't run for that time, it'll let you know and say, look, you need to use more of your battery or not to be able to run those devices for the full time based on the everyday production. This all backs up by the AI of the system and how it operates. So I'm going to go you through some live demos just now. So energy strategies that you have, so solar excess only. So you take your PV excess and you push it to the various devices. Then basically you can have your time of use mode to say, use the excess PV to charge the EV charger between 8 a.m. and 6 p.m., but from 10 p.m. to 8 p.m. auto charge with grid power because the power is cheap. Or you can set it to basically have it ready by a certain time It'll make sure that if the excess PV is less than 1.4 kilowatt, it cannot meet the time of use requirement. It then bypasses before 6 p.m. It'll make sure that that device has been charged or has been used. So this is typically for hot water. So you'll say to it, listen here, I need to use the excess PV for hot water only. But if we did not reach the minimum runtime by that time, go into smart bypass and use any available source to heat up the hot water. Then smart battery control, auto charging. So yeah, you can see when we reach 20% SOC, turn off the air conditioners. If we reach 60%, turn them on automatically. If we reach 20% again, turn them off. So again, that is a battery level control that you can set on these devices. Then your backup duration, basically your lights in your fridge is a must have, your oven and AC is a nice to have, and the pool pump and the hot tub is a not to have. So when you're entering backup mode, the not to haves will be off and the must haves will be on, but the nice to haves will also be on. The moment we reach 50% SOC, the nice to haves will also start shutting down and the must haves will stay on until the battery is completely depleted. Then the final one would be when you're running at Sigenergy AI mode. Once you've set it up in Sigenergy AI mode, it will start reading the consumption and looking at the patterns, and then it'll start making sure that your load consumption and your dynamic tariffs and weather data gets implemented, and it'll make sure that it has your must-haves on, your nice-to-haves also gets to run, and your not needed also gets powered whenever there's solar available. All right, so this enables you for guys that are running EVs to have the lowest cost smart charging. So from 9 a.m. to 5 p.m., we only charge with solar power, okay? The moment that we reach 1 a.m. to 6 a.m., we charge it off-peak electricity to make sure that our car is ready by 6 a.m. in the morning. This is also nice. So any heat pumps do not need a Shelly device or any device. It actually integrates into Sigenergy. There's a few new heat pumps that are coming out that will also integrate into Sigenergy directly. So yeah, you guys can see it here. So there's a multitude of Shelly devices. So you get the Pro versions, which are DIN rail DB mounted. They then have either come in a 1 p.m. or a 2 p.m. Basically what it does is it does, if it says PM, it means it does power management. If it's a Pro device, it means it's DIN rail mounted. If it's not Pro, it means it can be mounted inside a wall box or anywhere inside those devices. So if you've got the Shelly Pro versions, you'll have a LAN port, so you'll be able to connect it directly to your Ethernet. So the Shelly devices that are Pro devices look like a circuit breaker Ethernet connection. So if you are afraid that you do not have enough Wi-Fi coverage, you can directly hook it up to your routers. It basically has a live and neutral in, and then it's got the 2 switches, and it's got so this is a 2 device, so Shelly Pro 2. This basically means it's got 2 channels, so each channel is 16 amps. This is the Shelly 3, so this has got 3 channels in and out, and then you get the Shelly 4 PM Pro that's also got 4 out. So if it says PM on the device, it means it's got power measurement as well. So if you were to look at this, you will see that it says Shelly 1 PM. Then that means it can do power measurement. So this unit over here can measure up to 16 amps. So you've got your neutral in, you've got your live in, and then you've got your live out here on this port. But then you've got a switch port as well, and this is actually quite nice. So if you want to control lighting and measure the lighting itself, you can literally wire this in behind the wall box, then connect your normal switch that will switch this to the switch point. And what it will do is you'll be able to turn the switch off physically with the button on and off. But once you turn it off in the app, so let's say you've got the switch rocker in the on position and you turn it off in the app, the lights will actually turn off. And then when you go to the rocker, you switch it to off, it'll be off. And when you switch it on again, it'll turn on automatically. So you will be able to also, if the switch is in the off position, turn it on remotely through your Sigenergy app. So even if the switch itself in the wall is on the off position, you'll be able to still power measure and switch it on, because the switch literally just pulses to this specific unit where the automation actually overrides it. So you get it like this. This is a 1 p.m. So single channel power measurement, 16 amps. Then you get the black one, which is a 2 p.m., which is dual channel power measurement. Then you get the red one like this, which is the 1 channel power measurement. Then the black one, which is the 2 channel power measurement. And then obviously your bigger units, which is the 4 channel power measurement. Now, very, very, very important. Not all Shelly devices are added onto the Sigenergy platform. The devices that are there, when you go into your Sigenergy app, you'll be able to see those devices that are on there. And those will be the devices that are available to work with Sigenergy. So the main ones that will be used is the PM versions, because I wouldn't suggest installing a Shelly one that can just do switching without power measurement. But if you want to do that, you can do that if you really feel like you only want to switch. But I do feel that power measurement is actually where all of the great things come in. So I'm going to share my screen now and then run into the actual app from Shelly. All right, so this is our Brackengate office at the moment. So basically you'll see here's the smart devices. So we've basically got the lights currently running in the offices here. So first floor lights 2, first floor lights 1. If I go press on all, we'll be able to see all of the devices. It'll show me the consumption. So first floor lights 1. Here I'll be able to see the exact load of what that used for the day. If I look at the week, it'll be able to show me what the week load was. So this is this current week. Let's look at the month. That should be a little bit more. You can look at the various graphs of it. It'll show your home usage on these specific devices. And then you'll be able to turn it on and off. So currently the device is on, it's in manual mode. Now I can go into the device and I can say I want to change the backup management. So let's say that this load would have been something that we are looking at to switch on and switch off. So let's call it a geyser. I would then say that the cut-in range, or let's say the cut-in range is if I've got over 70% battery. So let's go 70% battery, I want it to be on. But if I've got less than 50% battery, it must switch off. So what it'll do is the moment we reach 50%, this load will turn off. But it won't turn on until we've reached over 70%. So it will, the moment we reach 49%, the battery will turn, or the device will turn off. Then it won't turn on again until we've reached the cut-in range. So then basically what happens is it'll leave your batteries to charge back up to 70%. So again, in a multi-person dwelling, you can have a situation where you say, I've got 24 flats, got one big system sitting in the basement with PV on the roof. We've got 24 geysers hooked up to Shelly devices. What we will do is we will shut down those geysers the moment we reach 50% battery state of charge, because we do not want to drain the battery that we are able to run off with during the night. This is just one usage pattern or that you can do with this. All right, then you've got your minimum running time. So you can say that we want to use these items, but it needs to run for a minimum of 60 minutes. So if it was, again, a water heater, we want that to run for a minimum of 60 minutes during the day. So these are all the various ways that you can set this up. Let's just go back again, and okay, here's your various devices. Then you can go to PV surplus priority. So here you can say solar producing source priority. I want to change it to rather use my battery versus using, so once we add the devices here, our devices are set up as manual because right now we're using manual control. The moment I set them off to use excess PV, they'll all appear over here. and we'll be able to set that which one, if there's excess solar, where does it go? So does it go to the battery first, then to the grid, then to the geyser, or it goes to the geyser first, then to the battery, then to the grid, or then to the air conditioning or whatever. So you'll have all of these devices that you can set up to be inside here. Obviously, we're using lighting control for it at the moment, so we don't want to use excess PV for it. Otherwise, the moment excess PV disappears, we might risk the lights going off. So at the moment, we're running those all in manual control. All right, brand new, also something that I can show you guys in the V3 app that's launching. Nice new feature that's coming now. Is you'll see that in our battery at the moment, there's 96.62 kilowatt hours. It's been raining the whole day in Cape Town, of which 7.28 kilowatt hours came from the sun, and 18%, which is 89 kilowatt hours, actually came from the grid. If you were running a generator, let's say for an hour, and there was another 30 kilowatt hours from the generator, you can then go to just discharge priority over here, and then you can say that our discharge priority is first use the energy that was from solar, then use the energy that was from grid, and lastly use the energy that was from the generator, because that's the most expensive energy when you use your generator to charge the battery. So nice new feature. You can actually see from which source the fuel inside the tank came, and you can decide which fuel to use up first. Another new feature that they've launched is the energy stats. So you can see here what your energy mix looks like. So if we were to say we've got 5.7 kilowatt hours that went to the battery, what came from solar? So from the 5.7 kilowatt hours, 94% was from solar and 5% was from the grid. Of the power that went to the load today, 25% came from the solar, 1.26% from the battery, and 72% came from the grid. If we look at what we exported, we actually exported 6 kilowatt hours from the battery, and 6% from the battery and 93% from solar. Also the other way around, if you want to see where all the grid power went, you can see that 0.09 went to the battery and 99.9 went to the loads today. Nice part about this is when you've got all of them selected, your graph will look like this. So let's go to a full sunny day. We go to last week on the 15th, which is nice. So here you can see this is what your graph looks like. We actually export it to the grid, but the moment I change that, it will show me the graph actually changes. If I change that, I want to see what the grid energy did, it just shows me what the grid energy did. If I say I want to see just the solar, it'll show me just the solar and the load consumed and all of that. And what's nice is if you look at these percentages, the 33, the 26, and the 62, you'll see them here, and it physically gives you the kilowatt hours that was consumed like that. So the moment you add smart devices and load ports, these devices will also appear inside these metrics, and you'll be able to see what went to the geyser, what went to the EV charger, what went to the heat pumps, what went to the pool pump. So all of that information will be available to you.